Weather charts are graphic charts that depict current or forecast weather. They provide an overall picture of the United States and should be used in the beginning stages of flight planning. Typically, weather charts show the movement of major weather systems and fronts. Surface analysis, weather depiction, and radar summary charts are sources of current weather information. Significant weather prognostic charts provide an overall forecast weather picture. The surface analysis chart, shown above, depicts an analysis of the current surface weather. This chart is a computer-prepared report that is transmitted every 3 hours and covers the contiguous 48 states and adjacent areas. A surface analysis chart shows the areas of high and low pressure, fronts, temperatures, dew points, wind directions and speeds, local weather, and visual obstructions. Surface weather observations for reporting points across the United States are also depicted on this chart. Each of these reporting points is illustrated by a station model. A station model includes 1. Type of observation. A round model indicates an official weather observer made the observation. A square model indicates the observation is from an automated station. 2. Sky cover. The station model depicts total sky cover and is shown as clear, scattered, broken, overcast, or obscured, partially obscured. 3. Clouds, represented by specific symbols. Low cloud symbols are placed beneath the station model, while middle and high cloud symbols are placed directly above the station model. Typically, only one type of cloud will be depicted with the station model. 4. Sea level pressure, given in 3 digits to the nearest tenth of a millibar, MB. For 1,000 millibars or greater, prefix a 10 to the 3 digits. For less than 1,000 millibars, prefix a 9 to the 3 digits. 5. Pressure change tendency. Pressure change in tenths of millibars over the past 3 hours. This is depicted directly below the sea level pressure. 6. Precipitation. A record of the precipitation that has fallen over the last 6 hours to the nearest hundredth of an inch. 7. Dew point, given in degrees Fahrenheit. 8. Present weather. Over 100 different weather symbols are used to describe the current weather. 9. Temperature, given in degrees Fahrenheit. 10. Wind. True direction of wind is given by the wind pointer line, indicating the direction from which the wind is coming. A short barb is equal to 5 knots of wind, a long barb is equal to 10 knots of wind, and a pennant is equal to 50 knots. A weather depiction chart, shown above, details surface conditions as derived from METAR and other surface observations. The weather depiction chart is prepared and transmitted by computer every 3 hours beginning at 0100 Zulu time and is valid at the time of the plotted data. It is designed to be used for flight planning by giving an overall picture of the weather across the United States. This type of chart typically displays major fronts or areas of high and low pressure. The weather depiction chart also provides a graphic display of IFR, VFR, and MVFR, marginal VFR weather. Areas of IFR conditions, ceilings less than 1,000 feet and visibility less than 3 miles, are shown by a hatched area outlined by a smooth line. MVFR regions, ceilings 1,000 to 3,000 feet, visibility 3 to 5 miles, are shown by a non-hatched area outlined by a smooth line. Areas of VFR, no ceiling or ceiling greater than 3,000 feet and visibility greater than 5 miles, are not outlined. Weather depiction charts show a modified station model that provides sky conditions in the form of total sky cover, cloud height or ceiling, weather and obstructions to visibility, but does not include wind or pressure readings like the surface analysis chart. A bracket symbol to the right of the station indicates the observation was made by an automated station. A radar summary chart is a graphically depicted collection of radar weather reports, SDs. The chart is published hourly at 35 minutes past the hour. It displays areas of precipitation as well as information regarding the characteristics of the precipitation. The radar summary chart is a valuable tool for pre-flight planning. It does, however, contain several limitations for the usage of the chart. This chart depicts only areas of precipitation. It will not show areas of clouds and fog with no appreciable precipitation, or the height of the tops and bases of the clouds. Radar summary charts are a depiction of current precipitation and should be used in conjunction with the current METAR and weather forecasts. A radar summary chart includes 1. No information. If information is not reported, the chart will say NA. If no echoes are detected, the chart will say NE. 2. Precipitation intensity contours. Intensity can be described as one of 6 levels and is shown on the chart by 3 contour intervals. 3. Height of tops. The heights of the echo tops are given in hundreds of feet MSL. 4. Movement of cells. Individual cell movement is indicated by an arrow pointing in the direction of movement. The speed of movement in knots is the number at the top of the arrowhead. LM indicates little movement. 5. Type of precipitation. The type of precipitation is marked on the chart using specific symbols. These symbols are not the same as used on the METAR charts. 6. Echo configuration. Echoes are shown as being areas, cells, or lines. 7. Weather watches. Severe weather watch areas for tornadoes and severe thunderstorms are depicted by boxes outlined with heavy dashed lines. Significant weather prognostic charts are available for low-level significant weather from the surface to flight level 240, 24,000 feet, also referred to as the 400 millibar level, and high-level significant weather from flight level 250 to flight level 600, 25,000 to 60,000 feet. The primary concern of this discussion is the low-level significant weather prognostic chart. The low-level chart comes in 2 forms: the 12 and 24-hour forecast chart and the 36 and 48-hour surface forecast chart. The first chart is a 4-panel chart that includes 12 and 24-hour forecasts for significant weather and surface weather. Charts are issued 4 times a day at 0000 Zulu, 0600 Zulu, 1200 Zulu, and 1800 Zulu. The valid time for the chart is printed on the lower left corner of each panel. The upper 2 panels show forecast significant weather, which may include non-convective turbulence, freezing levels, and IFR or MVFR weather. Areas of moderate or greater turbulence are enclosed in dashed lines. Numbers within these areas give the height of the turbulence in hundreds of feet MSL. Figures below the line show the anticipated base, while figures above the line show the top of the zone of turbulence. Also shown on this panel are areas of VFR, IFR, and MVFR. IFR areas are enclosed by solid lines, MVFR areas are enclosed by scalloped lines, and the remaining unenclosed area is designated VFR. Zigzag lines and the letters SFC indicate freezing levels in that area are at the surface. Freezing level height contours for the highest freezing level are drawn at 4,000-foot intervals with dashed lines. The lower 2 panels show the forecast surface weather and depicts the forecast locations and characteristics of pressure systems, fronts, and precipitation. Standard symbols are used to show fronts and pressure centers. Direction of movement of the pressure center is depicted by an arrow. The speed in knots is shown next to the arrow. In addition, areas of forecast precipitation and thunderstorms are outlined. Areas of precipitation that are shaded indicate at least 1/2 of the area is being affected by the precipitation. Unique symbols indicate the type of precipitation and the manner in which it occurs. Prognostic charts are an excellent source of information for pre-flight planning. However, this chart should be viewed in light of current conditions and specific local area forecasts. The 36 and 48-hour significant weather prognostic chart is an extension of the 12 and 24-hour forecast. It provides information regarding surface weather forecasts and includes a discussion of the forecast. This chart is issued twice a day. It typically contains forecast positions and characteristics of pressure patterns, fronts, and precipitation. An example of a 36 and 48-hour surface prognostic chart is shown above. Although ATC systems cannot always detect the presence or absence of clouds, they can often determine the intensity of a precipitation area, but the specific character of that area, snow, rain, hail, virga, etc., cannot be determined. For this reason, ATC refers to all weather areas displayed on ATC radar scopes as precipitation. ARTCC facilities normally use a weather and radar processor, WARP, to display a mosaic of data obtained from multiple NEXRAD sites. There is a time delay between actual conditions and those displayed to the controller. The precipitation data on the ARTCC controller's display could be up to 6 minutes old. The WARP processor is only used in ARTCC facilities. All ATC facilities using radar weather processors with the ability to determine precipitation intensity describe the intensity to pilots as light, moderate, heavy, or extreme. When the WARP is not available, a second system, the Narrowband Air Route Surveillance Radar, ARSR, can display two distinct levels of precipitation intensity that will be described to pilots as moderate and heavy to extreme. ATC facilities that cannot display the intensity levels of precipitation due to equipment limitations will describe the location of the precipitation area by geographic position or position relative to the aircraft. Since the intensity level is not available, the controller will state intensity unknown. ATC radar is not able to detect turbulence. Generally, turbulence can be expected to occur as the rate of rainfall or intensity of precipitation increases. Turbulence associated with greater rates of rainfall precipitation will normally be more severe than any associated with lesser rates of rainfall precipitation. Turbulence should be expected to occur near convective activity, even in clear air. Thunderstorms are a form of convective activity that implies severe or greater turbulence. Operation within 20 miles of thunderstorms should be approached with great caution, as the severity of turbulence can be much greater than the precipitation intensity might indicate. To the extent possible, controllers will issue pertinent information on weather and assist pilots in avoiding such areas when requested. Many aircraft manufacturers now include satellite weather services with new electronic flight display, EFD, and multifunction display, MFD, weather systems. EFDs give a pilot access to many of the satellite weather services available. Above are the weather products available to pilots, some of which include graphical NEXRAD data, graphical METAR data, SIGMETs, AIRMETs, graphical lightning strikes, temporary flight restrictions, and more. Pilots must be familiar with any EFD or MFD used and the satellite weather products available on the display. The information displayed using a satellite weather link is near real-time, but should not be thought of as instantaneous, up-to-date information. Each type of weather display is stamped with the age information on the MFD. The time is referenced from Zulu when the information was assembled at the ground station. The age should not be assumed to be the time when the FIS received the information from the satellite. Two types of weather are displayed on the screen: current weather and forecast data. Current information is displayed by an age, while the forecast data has a data stamp, shown above. Above is an example of a NEXRAD display on a PFD. The NEXRAD system is comprised of a series of 159 Weather Surveillance Radar 1988 Doppler WSR-88D sites situated throughout the United States, as well as selected overseas sites. The individual agencies that have control over the system are the National Weather Service, Air Force Weather Agency, AFWA, and the FAA. NEXRAD radar produces two levels of products, Level 2 and Level 3. All NEXRAD Level 2 data products are available through the National Climatic Data Center, NCDC. Level 2 data consists of the three meteorological base data quantities: reflectivity, mean radial velocity, and spectrum width. There are 41 products routinely available through the NCDC. Level 3 graphic products are available as digital images, color hard copy, grayscale hard copy, or acetate overlay copies. This information is then encoded and disseminated through the satellite weather system as well as other sources. NEXRAD Level 3 data for up to a 2,000-mile range can be displayed. It is important to realize that the radar image is not real-time and can be up to 5 minutes old. At no time should the images be used as storm-penetrating radar, nor to navigate through a line of storms. The image's display should only be used as a reference. In addition to utilizing the soft keys to activate the NEXRAD display, the pilot also has the option of setting the desired range. It is possible to zoom in on a specific area of the display in order to gain a more detailed picture of the radar display. Although NEXRAD is a compilation of stations across the country, there can be abnormalities associated with the system. Some of the abnormalities are ground clutter, strobes and spurious radar data, sun strobes when the radar antenna points directly at the sun, interference from buildings or mountains which may cause shadows, and military aircraft which deploy metallic dust and may reflect the radar signature. In addition to the abnormalities listed, the NEXRAD system does have some specific limitations. The NEXRAD base reflectivity does not provide adequate information from which to determine cloud layers or type of precipitation with respect to hail versus rain. Therefore, a pilot may mistake rain for hail. In addition, the base reflectivity is sampled at the minimum antenna elevation angle. With this minimum angle, an individual site cannot depict high-altitude storms directly over the station. This will leave an area of null coverage if an adjacent site does not also cover the affected area. Also, the resolution of the displayed data will pose additional concerns when the range is decreased. The minimum resolution for NEXRAD returns is 2 kilometers. This means that when the display range is zoomed in to approximately 10 miles, the individual square return boxes will be more prevalent. Each square will indicate the strongest display return within that 2-kilometer square area. AIRMET SIGMET information is available for the displayed viewing range on the MFD. Some displays are capable of displaying weather information for a 2,000-mile range. AIRMETs SIGMETs are displayed by dashed lines on the map shown above. The legend box denotes the various colors used to depict the AIRMETs, such as icing, turbulence, IFR weather, mountain obscuration, as well as surface winds. The great advantage of the graphically displayed AIRMET SIGMET boundary box is the pilot can see the extent of the area that the report covers. The pilot does not need to manually plot the points to determine the full extent of the coverage area. METARs can be displayed on the multifunction display. Each reporting station that has a METAR TAF available is depicted by a flag from the center of the airport symbol. Each flag is color-coded to depict the type of weather that is currently reported at that station. A legend is available to assist users in determining what each flag color represents. The graphical METAR display shows all available reporting stations within the set viewing range. By setting the range knob up to a 2,000-mile range, pilots can pan around the display map to check the current conditions of various airports along the route of flight. By understanding what each colored flag indicates, a pilot can quickly determine where weather patterns display marginal weather, IFR, or areas of VFR. These flags make it easy to determine weather at a specific airport should the need arise to divert from the intended airport of landing. While no weather forecast is guaranteed to be 100% accurate, pilots have access to a myriad of weather information on which to base flight decisions. Weather products available for pre-flight planning, to en route information received over the radio or via satellite link, provide the pilot with the most accurate and up-to-date information available. Each report provides a piece of the weather puzzle. Pilots must use several reports to get an overall picture and gain an understanding of the weather that will affect the safe completion of a flight. This concludes your introduction to aviation weather services. We hope you learned a lot. Please help us spread the word about Pilot Training System, and we look forward to further servicing your flight training needs.